to solve. Okay. Stuck. Okay. I don't know what has happened. Okay. Fine. We'll start. These problems I want you to solve. The first one. Do it for yourself. These are. If a body raises through a height of h, through a height of h in the nth second, then in n minus 1th second, it will raise through a height of h plus g, and in n plus 1th second, it will raise through a height of h minus g. All of you, I want you to try this problem and do it for yourself, please. మీకు దీనిలో డౌట్ ఉంటే మీరు చెప్పండి. You have to use the formula of Sn is equal to u plus a into n minus half. ఈ ఫార్ములా యూస్ చేసి మీరు సాల్వ్ చేయొచ్చు. ఓకే, బికాస్ nth సెకండ్ అన్నారు కాబట్టి, సో దట్ ఈస్ ద ఫార్ములా యూ కెన్ యూస్. ప్లీజ్ సాల్వ్ దట్. ట్రై ఇట్ ఫర్ యువర్ సెల్ఫ్. మీరు ఒకసారి ట్రై చేయండి. ఇఫ్ ద వెలాసిటీ of the body in nth second is v, then in n minus 1th second, this is vertical projection. Please understand, we are solving vertical projection situation. So vertical projection situation lo manam maatladutunnam. If the velocity of the body in nth second is v, then in n minus 1th second it is v plus g, and in n plus 1th second it is v minus g. while ascending. While ascending. This is very important. That is, while the body is going up. So please derive these conditions. Noted.
Noted, sir.
Okay, good. Now, third question. So these are questions. Please do it for yourself. Velocity of the particle. Velocity of the particle. 1 second. 1 second before reaching the highest point. Highest point is 9.8 meter second inverse. This is what you had to prove that. Next, question number 4. The change in velocity, the change in velocity over the complete journey. Over the complete journey. Over the complete journey is 2u downwards. It's 2u downwards. The change in the velocity in the complete journey is 2u downwards. So how do we do that? This I will do, not an issue. So here, this is up, okay, and here itself I can try everything. You see, upwards it went with the velocity u, that is u initial is u. While coming down, when the particle is coming down, that is vertical projection is what we are talking about. When the particle is coming down, u final, it will reach the final velocity. At the same point, it will reach down with the velocity of minus u, actually downwards. So the change in velocity, that is delta u, is u final minus u initial. So that is nothing but minus u, right? U final is minus u because it is downwards. U initial is minus u. So that is negative 2u. Negative 2u means what? 2u downwards. Clear? I hope it is clear for everyone. So this question is solved for you. Rest of the questions you have to solve for yourself.
Noted, sir.
Okay, good. Next, fifth one. The height . reached in the first second of ascent is equal to height of fall in the last second of descent. In the last second of descent. Okay. Irrespective of velocity of projection, all bodies pass through a height g by 2 in the last second of ascent. In the last second of ascent.
Clear, sir.
Yeah, good. Now, we'll go ahead. Next question. So this is like a point. Don't have to worry. Okay. For the air resistance case, okay, air resistance, I think they may not ask. Okay. A body is what is projected vertically up with a velocity of u from the ground in the presence of constant air resistance in the presence of constant air resistance R. If it reaches the ground, if it reaches the ground with a velocity v, with a velocity v, then time height of ascent is equal to height of descent. So here you don't have to prove this question. You don't have to prove. You just have to remember if you can. Noted?
Noted, sir.
No, good. Now, second case, case 2. Second case is time of ascent. Time of ascent, that is TA, that is mu divided by mg plus r. Time of descent is TD is equal to mu by mg minus r. Next, fourth, time of ascent is less than time of descent. If this is the condition, air resistance is taken into account. When you take air resistance into account, this is what you get. In the point number 5, V by U is equal to square root of mg minus r divided by mg plus r. So here V is less than U.
Noted, sir.
Okay, good. Now, if a body projected vertically up, vertically up, under air resistance, air resistance, retardation during the motion, retardation during the motion is A greater than G. It is greater than gravity. ఎందుకంటే air resistance కూడా will come into the picture. Now the next one. If the air resistance is considered, if air resistance is considered, if air resistance is considered, time of ascent decreases, time of ascent decreases, and time of descent increases. So this is the condition that when air resistance is considered. Otherwise, both are equal. So this is the practical case. This is the practical case. So we will not take the air resistance into consideration for all the calculations in general. Air resistance is taken into calculation. This is how the equations will be. So don't have to derive that. You need Newton's laws of motion to derive these things actually.
Noted, sir.
No. Let's do this. Next one. Next question. So this one we have to solve. A body is, this is a challenging one, is projected vertically upwards. From the ground. A body is projected vertically upwards from the ground. Is at the same height h. Is at the same height h. Is at the same height h from the ground. At two instants. Of time t1 and t2. At 2 instants of time t1 and t2, both measured from the instant of projection. Both measured from the instant of projection. Then h is equal to half g t1 t2. Got to prove this. Okay. And this is the first part. The second one is the velocity of projection. U is half G into T1 plus T2. Okay. The maximum height, the third thing is a very challenging question. The maximum height reached by the body is hit 1/8 of is G by 8 into T1 plus T2 whole square. Very famous question this is. Please note it.
Noted, sir.
Good. Let us try this now. So here you go. So this is like this, and now this is ground. First question explain chestanu. So now this is how it is projected. It has reached a maximum height of h anamata. First, it is projected with some velocity. So that velocity, it is u. It is projected with some velocity u. It has reached a maximum height of h max h. Okay. So it might have taken some time. Don't worry much about that. Now, what does the question says? It will reach a certain height of h. It will reach a certain height of h. This one is h. First, we have to understand the question, that is most important. It will reach certain height of h. Okay. While going up, it will reach this height h from the ground in time of t1. While coming down after a time of t2, it will reach the same height. That's what the question is. Okay. So we have to give the calculation. So we know A is equal to minus G very well. But how do you arrive this number? That is most important. When you are going up, your velocity is u, initial velocity is u. So h is equal to s is equal to ut plus half a t square. We will write. Now it took a time of t1 initially. So ut1 minus half g t1 square. This is how to start it. ut1 minus half gt1 square. This is how you get. Now it took a time of t1 while going up, and now the same time it went to the top and it has returned like this. Okay. Now while returning, what is this height it has covered? This is like h max minus h. H max minus h, right? I hope you got this distance how much it has covered, h max minus h. So you can write h max minus h is the distance. To cover this distance, and 2-3 quantities you need to take to solve this problem. Not easy, this one. Okay, h max minus h. Okay, then this is the height it has covered from the top, and at this point, on the topmost point, u is 0. Like this you can consider. At the topmost point, u is equal to 0. Now, the h max minus h distance is covered, u is 0. So you can write again ut plus half at square, but a is minus g. H max minus h is measured downwards. So we will write like this. Okay, negative because it is measured downwards. Ut minus half gt square. But what is t here? We have to see. What is this time? This entire time is t2. This is time of ascent. So t2 minus time of ascent we have to calculate. In this time of ascent, one bit is t1. So like that it will come. In the time of ascent, one part of it is t1. But you can calculate t2 minus time of ascent, you can calculate in the vertical projection mode. This is one thing. So like this we had to give the calculation. But there is another way, something called a vector mode. In that also we can do. This is the displacement. Displacement wise this much only, but it has taken the another time. So the initial velocity for this displacement is u. You will get ut2 minus half gt2 square. Okay, and then build up a relation between t1 t2, like that also one can do. So we can do this way also. So here, so when you equate this, you will get ut1 minus half gt1 square is equal to ut2 plus half gt2 square minus half gt2 square. So u into t2 minus t1 you will get, first you will get the initial velocity of projection, half gt2 square minus half gt1 square. Like this you can get. And now u is equal to half g into t2 square minus t1 square. You can do like this, divided by t2 minus t1. So this is the easiest way of getting this. So half g into t2 square minus t1 square, you will get it as t1 plus t2. Okay, t2 plus t1 into t2 minus t1 divided by t2 minus t1. You will get t2 minus t1. You can cut. So the initial velocity of projection you got, u is equal to half g into t2 minus t2 plus t1. T1 plus T2. So this is how you get the initial velocity of projection. So this one you can plug in here. You can plug in any one of the equations, you will get the answer. So let's see that. So this one, what I am telling you is the longest method, but this one is the shortest. Okay. You don't have to calculate the H max, but they have given the calculation, so we can do that. So here you go. So when you substitute that, H is equal to half g into t1 plus t2, okay, into t1 minus half g t1 square is what you have. And now you see half g t1 square plus half g t1 t2 minus half g t1 square. Half g t1 square is out. So you got h is equal to half g t1 t2. So this is how you can generate the answer. So that what we have done is the vector mode. This is called vector mode of calculation. Okay.
Noted, sir.
Noted. Now, for the maximum height reached, for maximum height reached. So how do we do the maximum height reached? We use the equation v square minus u square equal to 2as. So as is equal to h max, a is equal to minus g. Okay. So here u v is 0. Why final velocity is 0? At maximum height, the velocity is 0. So you have minus u square is equal to minus 2g h max. What is u? We just calculated, that is half g into t1 plus t2, right? Just calculated that. And now just substitute those things. That's it. Done. So h max, you get it as half g into t1 plus t2 whole square. You will get it half g square. So you will get it right. Right. Substitute this here, you will get it. Okay. So sufficient today. So tomorrow we will solve some more questions, and again some problems we have to solve. Different variety of problems will be there in this straight line motion. So you have to see. This may take some time, no problem, but I want you to, even you spend some time, I want you to gain the concept here.